From Vetri and Veterinary Chemistry. So today now we are going to see the JEE main question, previous year questions. So previous year questions are very important. Now we are moving to the question is correct order of the acid strength of the following carboxylic acid. They are asking the acid strength. Let us go and see the option. So they are asking the compartment, immediately go and see the option, and based on the sign what is it indicates, they are asking that what order is, they are asking the decreasing order, that is put it in your mind. Okay, so who is the highest one? Just to have a glance on the acids. We can see all are the acids, of course, COOH. So everything is the acids. Okay, the main difference is here, what I can say is it is aliphatic acid and aromatic acid. So aromatic acid are more acidic than aliphatic acid, point number 1. Next, by looking this one, what is this triple bond? What is this is double bond, and here there is no double bond at all. So what it indicates, that is sp3, this is your, now here is of course I am using the plate, triple bond, double bond, single bond. This is your sp2 and sp3. Here it is more acidic, that is your S character is it's having 50% and 50% you might be known. So more S character, more electronegativity, that means called more acid strength. That means what? This bond is pulling the electron most towards itself. So everything moving towards means this is easy to eliminate. This is easy to remove on strong acid. So knowledge number 1, acid strength means easy to remove. Now what is the factor is because of the sp hybridization, this is more S character, more electronegativity, so it is attract the electron, all electrons are moving towards this side, it is easy to move. So comparing this one, I am giving for the first one is the ranking number 1. So this is the first knowledge. Now this one you can see is the sp2 hybridization, and this is also to sp2. So now these two are in the ranking, same platform, you keep it as it is. Here it is sp3, so you keep it is the least. So first is the best and the fourth one is the least. You come and see the options. The first one is the best, mean you are provided with the one option is available, again the option. So remaining options are, you can clear it, just don't worry about it. Again having the both are having the same option 4. So the competition is between 2 and 3 has to decide. Okay, now come and see. So you have to focus now on 2 and 3. Already I told. This is also sp2, this is also sp2. Okay, since it is the benzoic acid, this is more acidic, don't come to the conclusion. Okay, what is the breaking point is here, the important point is here. This one, that is, come here. Here what is it? This is the electron, what is the methoxy group is electron releasing. That is called the plus I effect. So more plus electron releasing, that means called, this is not easy to come. So everything should come, then only easy to go. But because of electron density is towards the ring, it is less acidic. Why? Because of electron releasing group. So comparing this, 2 is better than 3. Now come and go to the answer. Option 2 is better than 3. 2 is better than 3. So this is your option. Okay, children. Point number 1. What is it? You compare sp3, sp2 hybridization. Afterwards, so you are selecting the number 1. This is sp number 1 and this is the log. Then competition between these two. Here it is benzoic acid, with that don't come to conclusion. What is here indicating is the electron releasing group plus side. Electron density increases means acid strength decreases, so it is weaker. Okay. Okay, next question. Now let us see the next question. JEE main previous year question. Which compound will easily produce a precipitate with the silver nitrate? So what is the thing? You can see the reactant, all are having the Br group. So Br minus ion with the silver nitrate. Let us see what is the reaction is. Br minus should produce from the organic compound with the silver nitrate. It gives AgBr. So this is the reaction what to be happen. So what is the knowledge is, this is point number 1. Number 2 is, whichever is easy to give the BR is going to be a stable precipitate. So easy to give. When it will be easy to give, more stable will give. So who will we give is more stable or most stable compound will give easily the BR. Or I can say after BR is removing, the carbocation formed should be stable. That is the stable carbocation. That is coming to the knowledge. Here in each case you will see the result. So if you are removing here, means what will happen in the positive charge is created here. Okay, now what about this is, we know a very important point. Always keep it in the mind. Positive charge on the ring. This is the phenyl group is very unstable. Very important point, unstable, because it's having more energy. Apart from that, this electron cannot go and occupy this orbital because it is perpendicular. This is p orbital is in this plane, means this empty orbital is in the horizontal plane. They are 90 degree with each other, so conjugate or resonance is not possible. So this is not stable. Based on the knowledge, it is not stable. That is point number 1. Next one is the positive charges on the carbon atom, which is more electronegative. So we cannot, it is not stable. Now coming to the point. Second one also the same reason. Same you are removing here on the same carbon ring, it is having positive. Both the reasons are the same. So this is also not easy to form. This is also not easy to form. The third one, simply same reason. You are removing here on the benzene ring, you are positive charge. Here what is the difference is here? Not at all pi electrons is not, even the pi electrons is not available. Not think about your, what is it called, resonance. Whereas in this case, what we can see is, after removal of this, what we are getting is, after removal, you can see here, this one. Yes. Here you are having the positive charge on the ring. That is on the ring, on the carbon atom. It cannot be overlapped with the next one. And apart from that, it is stable. How it is stable means, this towards the positive charge, this electron is moving and this is moving and this is. Okay, what is it? This ion is stabilized by resonance. It is stabilized, very important point, by resonance. Now it is related with the positive ion. Because of positive ion, the electron is attracted towards here. So shifting takes place, resonance is stabilized. So because of the resonance stable, this is easy to go, and this is the answer which easily produces the precipitate with the silver nitrate ion. Simple knowledge. Okay children, now we are going to see the next JEE previous year question. Count the number of favorable protonation site in the following structure. Here you are provided with one structure where you are having many number of nitrogen atom. How many sites you can protonate? So what is the meaning of protonation? Means H plus is going to attack. So how many places are ready to receive the H plus? That is the question. Okay, how many? 1 number, 2 number, 3 or 4? That is the question. Okay, before going to the structure, this knowledge, let us see the 3 important compound of nitrogen compound. Now let us see the, here it is the question. Now to discuss about the knowledge, now you should know what is individually. One, what this compound is aniline. Next this compound I am going to give us the pyridine. Pyridine. Next one is your pyrrole. This is for all the compounds known to you. So first knowledge is on the nitrogen atom you are having the lone pass. So all the nitrogen, in the question also all are having lone pass. There is no doubt. Here now what is the thing is, it is going to, the H plus is going to approach mean that particular compound should have the structure should have, that is the knowledge, should have the free electron, or I can say the availability electron, or I can say the lone pass. So that is meaning of it, the lone pass should be available for the H plus, mean it is protonation. Let us see now what happening your lone pass. Now in the aniline, this lone pair is free or not free? This is not free. It is engaging in the what is it called resonance, because this is okay. The electron is moving shift here, so this is moving here and this is moving. So this lone pair is not free. That means what? Not protonation. It is not possible. If it is like aniline type, means not possible. In the case of pyridine, what happened to the lone pair is it is available. This lone pair is available. This lone pair is available. Let me write here. Lone pair is available for protonation. How it is available, you can ask. Now the thing is, here in this one, this lone pair is in the position is perpendicular this one on the benzene. If you want to see, explain me. Now let us see here the same benzene ring. Okay, what happening is on the each carbon atom, your p electrons are available in this plane, of course. So all are having the one electron, of course. Whereas here it is nitrogen, mean here it is p orbital of carbon. Your nitrogen is lone pair is available here. So this nitrogen plane is like this, carbon is nitrogen like this, carbon is like that. So this electron of nitrogen cannot overlap with the carbon, so not overlap, or I can say it is free. So this is the reason. So it is available protonated. You can possible. Coming to this point, what is this here is, here it is automatically, it is not available. That means it is engaging in the resonance, not available. Here the reason is the resonance. Here too, this is the negative electron. So moving here, so this is. So like that, what is happening? Conjugate is possible. So not available for protonation. Now come and apply the knowledge here. Final knowledge, what is it? If it is pyridine, mean available for protonation. Let us come and see here. What is this? Is your aniline type. So this corner is not possible. What about this is your what is called pyridine type? It is pyridine. So this part is free to what is it called as a protonation. This is also, you can say, hexagonal link pyridine. So it is, this is also possible. Here what happened to this? This corner is not possible. Here what is it? You can call as a pentagonal ring. And this is the thing. Okay. So now it is, this is also, even it is a pentagonal, this is in the pyridine format. That is like the lone pair is on nitrogen, it is also possible. Here what is happening? The lone pair is involved in the resonance. That is, it is coming here. That is, or I can say as a, with this is the pyrrole corner. So it is not possible. So overall, how many numbers tick are there? Available is 3. So 3 corners are available for protonation. Interesting question. Thank you, children.